Welcome, Calculus BC. This is lesson 4.3, the second fundamental theorem of calculus, rate graph, and average of a function. Let's go. All right, so here's what the second fundamental theorem looks like. It's kind of weird, but kind of easy. So if you have a constant a and you're integrating, but you're deriving an integral, and one of the integrals is a variable limit. Well, we can say, since deriving and integral cancel each other out of f of t dt, I can just plug in that variable x for the variable of the function. Okay, and that just works. So let's say, before I do that, so that means like the answer to this one right here, I mean, not that one, just this one right here, would just be 2x minus 3. All right? And you're like, really? Prove it to me. Well, let's prove it to you. So if you integrate this one, let's say you just integrate it first. So integral of 2t is going to be 2t squared over 2, which is a t squared, minus 3t, and from 0 to x. All right, so let's plug in those variables. You plug in x, you would get x squared minus 3 times x. And then minus plug in 0 would be 0 squared minus 3, 0. Which would just be x squared minus 3x. So now that's what the integral of this thing equals. So now we have to actually derive it. So the derivative, instead of this integral right here, of x squared minus 3x, and derivative of that is 2x minus 3. Wow. The cool thing is it doesn't matter what this number is. This can be 0. This could be 10. What if that was 10? That means instead of 0 squared, it's 10 squared minus 30 times 10 is going to be 100 minus 30 is 70, so negative 70. But then if you had minus 70 over here derived, that just goes to 0 anyways. So it works out that way. Plug that variable in for the, not in that case. Plug that variable in right here, and there's your answer. All right, so even in this case, what's the derivative of x, f prime of t? Well, that would just be f of x, because the integral of f prime of t is going to be f of t from 10 to x. So it's f of x minus f of 10, and f of 10 is a constant. So when you derived f of x minus f of 10, f of x just becomes f prime of x, and then this goes to 0 because it's constant. We talked about that last time. So cool. That's how it works when it's just a variable. It doesn't matter what the number is. However, there are some exceptions. What if it's like not just the variable x, it's like an x squared or 2x or x cubed? So you have to chain it. I'm just going to say chain it. So if I was deriving this integral, it's going to be, oh, that's a really weird format. Oh well. So it's going to be f of prime of x squared times the derivative of x squared, 2x. All right? Why does that work? Let's just do it in 2 steps. If you integrated this first, just that integration right here, it'd be f of x squared minus f of 0. And then if you derived that, well, the derivative of f of x squared is going to be f prime of x squared, but you have to chain rule the inside, times 2x, and the derivative of f of 0 is just 0. So, hey, it works out. Now, what if there's x's on the top and bottom? Well, if you have it on the bottom, you subtract the bottom. If there's a variable on the bottom, subtract. So this answer would have been f of prime of 2x times the chain of that 2x, which is 2, minus f prime of x cubed times the chain of that 3x squared. Weird examples. All right, and this is just what I said. So here it is again. If you derive derivative of an x cubed, doesn't matter what the number is, it's going to be, let's say, it's going to be x cubed squared minus 2 times x cubed times 3x squared, the derivative of this guy. So the reason this always works is, if that limit was just x, the derivative of x is 1. So really we're doing this anyways, but if this was just an x, it would just be a 1, so it doesn't matter. All right. And same thing. If x was on the bottom, there's two ways to think about this. One, you're always subtracting this one, so it'll be a negative 2 times x minus 3. Another way to think about this, when you integrate, you can flip them upside down, so I can change the order from x to 0. But remember, when you do that, you have to negate this. You have to make it negative. So from 0 to x of 2t minus 3. These are equivalent. Like, you can flip these, but you must also flip the sign on the outside. All right, rate graphs. So just watch this example. This is a graph of a rate on the y-axis, inches per hour, and time on the x-axis. So this models rainfall in inches per hour from midnight until 6 a.m. So if I have a rate on the outside, if you integrate this area under the curve, like what does it represent? Well, actually represents how much water you have or how much rain you have. Okay, so this is like integrate a rate graph, how much rain you've had in that time. All right, so write a complete sentence to explain what point A on the graph represents. So I would say point A on that graph represents how much rain, the rate of rain at 3 hours after midnight. So at 3 a.m., the rate of rainfall is 1 inch per minute. All right, what's the slope between graphs point A and point B? The slope right there is 0. It's a flat line. And what does it mean? What does the answer for 6 mean? Well, it means the rate of rainfall between A and B is not changing. So it's just staying at 1 inch per hour for that time. All right. What is the slope of the graph between B and C? Well, the slope of the graph is rise over run. So you go down 1, careful of your scale, and then over 1. So it's a -1 slope. Ready complete sentence to explain that. That means this is a slope. The rate of water, the rate of rainfall is actually changing at -1 inches per hour squared. Think of it like acceleration now. So it's changing at -1 inches per hour squared. All right. Area under the curve between 3 and 5 of R of t. Now, what you can look at, you can see this is two shapes. This is a rectangle. I thought I heard knocking. Rectangle shape. This is 1 wide and 1 tall. So it's going to be the area of this rectangle is 1. And that means the area of this thing is going to be 1/2. So my total answer is 1 and 1/2, or 1.5. What does that 1.5 mean? That means I've had 1.5 inches of water, of rainfall in that time. Because you integrate that, it's inches. All right, we're going to save some of those. Average value function. So sometimes I want to find the average height of it. Think of the average y value. So if I'm going from here to here of this curve, I want to figure out the average y value. The average, like average area under the curve, you got this area right here. Your average is probably like something like here. That's like if this part fell into this gap, it would like be a perfectly straight line, and there'd be your average. Well, how do you figure out average? It's how you figure out average of anything. It's the sum over the quantity, how much you have. And in calculus, we write it like this. The average value of function is the integral, the definite integral of that function divided by, b minus a, and where b and a are your upper and lower limits. Sometimes we write it like this. If you want to write side by side, it's fine. Want to write it this way? I don't care. Just note, it must be continuous on that domain from A to B. So let's take an example. Here's the function x cubed minus x. From the interval from 0 to 2, we want to find, 0 to 2, we want to find the average value, which is like the average y value. So I'm going to integrate that, x cubed minus x dx, from 0 to 2. And you also want to multiply it by the difference, b minus a, so 2 minus 0. All right, so that'll just be 1/2. So integrating this, I get x to the 4th over 4 minus x squared over 2 from 0 to 2. And so doing the math right there, that's going to be 2 to the 4th over 4 minus 2 squared over 2, and minus plugging in 0, 0 to the 4th over 4 minus 0 squared over 2. That just goes to 0. 2 to the 4th is 16 over 4 minus 4 over 2, which is going to be 4 minus 2, just 2. But don't forget this 1/2. So dropping that down, I get 1/2 times 2. So my answer is 1. The average height between those two would actually be 1. So like a line right here, the area under this curve, which is like this negative area, and this positive area, if you added all that up, it would average out, well, not all that area, all this area. You average it out, it would average out to 1. All right, and what's cool is I can use my calculator to find, maybe I want to find on the graph, like where does it actually equal the average height? So it looks like it equals it about here, but what's that as a point? Sometimes you have to find that. So we know my height, my average has got to be 1, so I got to find out when f of x equals 1. I got to figure out that x value, or FTC. So when x cubed minus x equals 1. So we're going to pull out this calculator now. All right, turn it back on. Oops, that's not how you turn it on. Turn it back on. Okay, so we're going to change our graph to be x cubed minus 6x. So if you have a TI-89, you can just use the solve function. But I'm going to pretend I don't, like an 84. So how do I do that? So here's the picture of the graph right here, right? And what I want to do is I'm going to also graph y equals 1. And so I have them crossing like right, where do we actually cross? That's really the interval? That doesn't seem right. Did I type that in right? Oh, it's not 6x. Oh, come on. 6x, it's not 6x, it's minus x. All right, just double speed it, folks, if I'm too slow. So there we go, and then it's hard to kind of see, so I'm going to zoom in a little bit because I can. I'm going to zoom in right here. Okay, so it's crossing right here, and that's when I want to find out what that point is. So I'm going to use my intersection function. So one of the 4 things you have to do. So first curve and second curve, it doesn't matter. Just choose them both. And I know it's around this point, so in 89 you have to choose lower and then upper bound. And then it doesn't ask you to guess. And my intersection point's at 1.324. So my C in this case is 1.324. If you plug that into this function, it should equal 1. All right, that's it. Stop.